service, and we are recording. So welcome, ladies and gentlemen, to our Introduction Networks class for this week, our ITC class for, in this case, it's March 12th. We're going to do, again, a little bit something different today because I do have a smart board I'm working with. I'm going to jump ahead because I want to introduce to you, just like I do in my normal class, I want to jump ahead and go ahead and give you the, and I'm going to turn my video off, folks, right now because there's no need for you to see my ugly mug here. Let me find where I can turn the video off. Where's my video setting? I lost it. Y'all see where I'm going? Nope, I mean it. Oh, there it is. Okay, turn my video off. Now what I'm going to do is I'm going to share the desktop. It should give you this. Can everybody see the Chapter 7 IP addressing?
Yes, I can.
Okay, great. We're going to jump ahead to Chapter 7. Now, I know, obviously, we're on Chapter 4, Chapter 5. That's the data link layer of the OSI model, looking at framing, looking at the physical layer, creating cables. I'm not saying those things are not important, but I do want to jump ahead and give you Chapter 7 and talk about IP addressing because this is probably, OSI model is one of the main topics of this course. Basic router and switch config, main topic. But IP addressing is something that you're going to have every single day of your life in networking. Especially as we move forward. I asked each of you one time before how many devices you had in your particular network. Most of you average between 12 and 10 to 20, honestly. And as we continue to have the Internet of Things and we have stuff continue to grow, we're going to have more and more. There are two main forms of IP addressing we have. We have, obviously, it moved on its own. We have, obviously, IPv4 and IPv6. I'm going to focus on IPv4 today, which is the version that we are currently using for most of our stuff. I'll also, if you have questions, most of you have, if you don't have a video, go ahead, you can use chat to talk to me, but I have to pull it down and look at it. But most of you have seen an IPv4 address at least, and one of the things that, let me grab my pen, here's one of the cool things about this new board. When we look at IPv4 addresses, you'll notice that the computer sees it in binary. We're not very good at binary, so what we want to do is, I'm going to make this a little bit smaller here. Okay. What we want to do is we want to be able to write it in dotted decimal. So we may write it as 192.168.12.10. Okay? So humans like it in dotted decimal. Computers want it in binary. So you're going to see it represented in binary. It's important that you do understand binary and that you're able to write binary, at least in basics when it comes down to octets. But you're not going to have to do a large amount of math. I had a good question the other day where somebody asked me, hey, how bad is the math in networking? I said, well, can you count to 2? And pretty much, ones and zeros and go up to an octet, and we're pretty good. Now, when we get to IPv6, which is 128 bits and hexadecimal, things are a little bit harder, but it's not that bad. So,
yeah, but we can drop all the zeros.
Yeah, exactly. We can drop all the zeros. So we're looking here at different types of numbering systems. There's a video here looking at base 2 versus base 10. One of the things I will tell you is that we've used numbering systems our entire life. We've just used a base 10 system. Why do you think we use base 10? Anybody know? Well, look at your hands. Yeah, look at your hands. We got 10 fingers. If we had evolved with 8 fingers, we'd have a base 8 system more likely. But we've got a base 10 system, which means we have the digits 0 to 9, okay? And we go, 10 to the 0, 10 to the 1, 10 to the 2. So let's say this is 1, excuse me, yep, this is 10 and 100. So we've got a 1's position, a 10's position, and a 100's position. So when we actually have something like 150, what we've got is no 1's, 5 10's, and 1 100, which would end up giving you 100 plus 50 plus 0, and that's 150. So we've been doing that all along. That's the kind of thing we've been doing. Now we're just going to do it on a base 10 numbering system. We're not going to do it on, base 2 numbering system instead of base 10. Again, positional notation, you see the radix, and this is the base 10. Positioning the number, and this is exactly what I was showing you. And this is a 10 to the third. This is 3,210. And you'll notice that we have 3 times 100, 3 times 1,000, 2 times 100, 1 times 10, and 0 times 1, or 0, 1. Really, you end up saying you have 0 ones, 1 10, 200s, and 3 1,000s. This, I'm pretty sure I don't have to spend a whole lot of time with that on with this particular group. But this is what we really need to start thinking about is an octet. So we're going to look at an octet is 8 bits, and that's what an IPv4 address consists of, is 4 octets. 8 times 4 is 32. An octopus has how many arms? 8. An octagon has 8 sides. So an octet has 8 bits. Each one of those representing a position, each one having a position in the number, to the 7th, to the 6th, to the 5th, to the 4th, to the 3rd, so on and so forth. Now, I just took a cert test today, and in fact, what I did before I started the test is I sat down, and I do this quite often before I start any certification test. Come on, man. You didn't do my, yeah, I can do that and just do a screenshot. Where is it? Here, it's got screen sketch. But I always, when I'm doing a test, before I even start, I always put on the right hand or left hand side for the left hand. I actually do this. I write it out because I'm done. Oh, I can't do it. 2 to the 4th, 2 to the 5th. So I do 1, 2, 4, 8, 16, and I do 30. So I do it all the way up to at least, a lot of times I'll do it up to the 15th power. That way I just don't make any dumb mistakes during the certification test.
Oh, okay. I was wondering because I normally do 128, 64, 32, 16.
Yeah. And so I do this on any time I'm taking a Cisco test, just to, in case they ask me something about binary, I don't have to, use my brain power to figure it out. And also I just don't make a dumb mistake, which is easy to do when you're stressed out taking a test. Speaking of which, I did pass security fundamentals today for SecOps. Woohoo! So now I've only got to take the SecOps portion of the CCNA CyberOps, which is good. So, what are we going to do with binary to decimal conversion? So if you've got a binary and you want to convert it to decimal, you use the addition function. So in other words, you look at a binary number, 11000000, and you go in and say, okay, the 128-bit position's turned on, the 64-bit position's turned on, 32, 16, 8, 4, 2, 1. So you can see that you add together 128 and 64 and you get 192, and that's your dotted decimal value. Go to the next one, you'll see the positions turned on and you add them. So when you're going from binary to decimal, you use the addition method. Pretty simple. Any questions on that? Most of you probably know this already. Okay. Now, there is an activity you can do here, and one of the things I like about this is it actually gives you a binary number, and you can check it. So if you put in a number that's incorrect, let's just say 123, check it and it's wrong, it'll tell you it's wrong, and it will then, you can also reset and get a new number if you want to do that. You can actually continue, do as many as you want. So it's kind of cool, new number. So this is good for your students. So like this, we know it's 3. Which, by the way, if any of you watched some movies that supposedly have, quote, hackers on them, and they put in an IP address of 380 something, what's the maximum value you can have in an octet?
255.
255. So basically, when you look at an octet, one of the things I teach my students is I teach them to learn the following. 6, 7, 8. And I wish I had $1 for every time I put a 0 on the board. Okay? All right, so 128, if 1 is turned on. If it's the first 2 turned on, and I like this is so much better than trying to write it on the screen. It's 192. What about the first 3? Anybody know? What would it be? Let's say I needed to convert this to binary. What would I do?
Well, add 32 to 192, but.
Yep, so you take 128 plus 64 plus 32, because those are 2 to the 7th, 2 to the 6th, and 2 to the 5th. So it's 224. And then 1, 2, 3, 4, 5, 6, 7, 8. 240. 1, 2, 3, 4, 5, 6, 7, 8. Equals, what is it? 248. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6.
Well, thank you.
6, 7, 8 is 252. 1, 2, 3, 4, 5, 6, 7, 8. 254. And by the way, folks, anybody in this group left-handed? Nobody's left-handed? All right, you all failed. No, I'm just kidding. I'm left-handed, so my handwriting's horrible. I apologize ahead of time. If we're going to be using this tool, it's kind of cool, though. My handwriting's bad, but it's not quite as bad as it is on paper. Like I think I told the class, too, remember I have been hit by a truck and paralyzed from the neck down, so my hands do not work as well as they used to. Be honest with you, it's kind of funny. My wife says even though my hands don't work like they used to, my handwriting's really no worse than it was before, which is extremely funny. But you see here, if you can memorize, this is an octet. Remember, each position to the 7th, to the 6th, to the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st, to the 0. So position 1, 2, 4, 8, 16, 32, 64, and 128. Okay? So those are the positions. So when you look at this binary number, if the first one's turned on, it's just 128. First two, it's 128 plus 64, which gives you 192. The reason I teach this and have my students memorize this is because the neat thing is you have I'm sorry, I'm getting signed up for it. No, they don't have signed up. Just give me that. They'll be fine. The neat thing is, let's imagine I get a binary number that's this: 4, 5, 6, 7, 8. Okay? Now, normally I had to go through, okay, it's 128 plus 64 plus, well, there are no 32s, there are no 16s, there are no 8s, there are no 4s, there's a 2, and there's a 1. Then I get my value, right? But why not just say, okay, it's 192 plus 3. So this is 195. So you can learn shortcuts, all right? The other thing you're going to learn is if the 2 to the 0-bit position is turned on, what is the number always going to be?
What now?
If the 2 to the 0-bit position is, if the first bit position is turned on, the number is always going to be what kind of decimal number? It's always going to be odd. Because if the 1 is on, it has to be odd. Okay? Now, if this position is off, okay, so 1, 0, then it would be 194, right? So if the 2 to the 0 position is off, the decimal number should always be even. If it's on, it should be odd. And that's something you can kind of check yourself with when you're doing conversions. You can sit down and say, okay, and in fact, let's imagine a test scenario where they give you a binary number and they say, I want you to convert this, and it's a number that ends in a 0, and all the numbers but 1 are odd. Aha. Bingo. You don't have to spend 10 minutes converting that to decimal. You know immediately that the answer is the one that's even because the 2 to the 0-bit position is not turned on. Questions about that? Questions about the conversion from binary to decimal?
No problem.
All right, how about going the other way? All right, how about going from decimal to binary? So let's imagine, and I'm going to go back to the curriculum for this because it's easier just to quickly show you. I've already got the basics of it. The decimal to binary, remember we do in binary to decimal is the addition method. Well, decimal to binary is the subtraction method. In other words, can you subtract 128 from it? If you can, Then you subtract it and turn that bit position off. Can you subtract 64? Can you subtract 32? So when we look at this, let's imagine our number is, let's just do fairly easy one. Let's do 194. All right. So can we subtract 128 from 194?
Yeah.
Yes.
Yeah. Okay. What am I left over with? Let's turn that on. It's 2 to the 7th position, to the 6th, to the 5th, to the 4th,
64 and
1 to the 0. Okay, so we know this is 8, right? 14, 6, 66. Is that right?
right.
All right. Now, can I subtract 64 from 66?
Yes, you can.
Okay. So I turn that bit position on, and what am I left with? 2, right?
2.
So can I subtract 32 from 2?
No.
Nope. I can't subtract 16 from it. I can't subtract 8, and I can't subtract 4. But I can subtract 2 from it, right?
Yes.
So turn that on. Bingo. This is 194 in binary. So we just converted from decimal to binary. This is what your computer does every time it uses an IP address that you put on it, because computers cannot understand dotted decimal. That's mine. They understand binary only. All right. So remember, if we're converting from a decimal, we use the addition. So let me do this. I'm going to give you 223. I want you all to convert that one on a piece of paper there at your desk. Take a couple seconds and convert that one. By the way, how many of y'all like this so far? As far as the system.
What? Okay.
I said, how do you like the smartboard system so far we're using?
Oh, looks good. Oh.
Yeah, I like it too. I'm impressed.
Is that smart? Is that actually the smart, or is that a different brand?
No, this is actually a Dell. We found that Dell makes their own, and it's a whole lot cheaper than a lot of the other brands. This is a Dell.
Oh yeah, we went with Focus for all of the ones in our latest high school. The smart is
that
way
too,
too
but
much
I'll tell
money.
you right now that we're actually going to probably switch to these Dells, because with a built-in computer, so this thing actually has its own computer built in, it was still less than the InFocus. It was a Dell C55, Dell C55 18QT is what we got.
Yeah, I was wondering where you got the Flat Frog whiteboard from. I was like looking to Google it.
Yeah, Flat Frog. I don't know where y'all got Flat Frog. Do you just go down with
It came bundled with it. They told us to go to Flat Frog / Dale as a bundle.
Yeah, they'll recommend using the Flat Frog. It works the best with their PCs, with their
I like it. Yeah, I like it too. I think it's pretty cool. All right, so if we're going to convert this, can you subtract 128 from 223?
Yes. Yes.
Oh, yeah. So let's turn that on. So let's do our math here. So we're up to this. Let's see, we're going to go all the way down to here. So what we got left?
Right here, 64.
64.
Okay. Is it 64? Not 64. 128 and 223 is what?
95.
95.
Oh, no, yeah. I thought you were asking for the next number, 64. Yeah,
95. Okay. So now, can we subtract 64 from 95?
Yes.
All day long? Yeah. This is 31. We can't subtract 32, can we?
No.
I'll show you a trick, though. Guess what?
It's a 15, so you can put all the 1 into it.
Yeah, I think that's pretty much, that's going to be the answer. But watch this. I subtract 16 from it. Yep. Okay, so what do I get? There's 2, 5, 15. Then I subtract 8, which gives me what? 6, 421.
7.
7 is the 7. Yeah, 7. So it's 421. So I subtract 4, between 3, subtract 2, subtract 1, and boom, that's it. So 110111111. This equals 223. Okay. So again, using the addition method, you're able to convert from decimal to binary. Very good. You're going to need that skill, and your students are going to need that skill for the actual exam.
So we're moving into VLSM?
Do what?
So does this mean we're moving on into VLSM?
We will. One of the things I do they don't do in the curriculum, I actually teach classical addressing first, and then do VLSM. And I'll tell you why in just a minute. Okay? All right, so I'm going to bypass that. You've got another utility for that, and there's a game. Now, what I want to do at this point is talk about the fact that all IP addresses really have multiple portions to them. Same quick word. Up there. Yeah. In other words, you've got, really there's possibly 3 portions. You do have a network portion, you do have a host portion, and we're going to talk about also the possibility of a subnetwork portion, which technically many texts roll into this network portion because it is still part of the network. But one of the things you will learn is that every one of an IP address does have some portion that's network and some portion that is host. All right. Now, one of the things that's kind of cool is many people don't understand what a subnet mask is for. Now, the book definition of a subnet mask, okay, this is a subnet mask, and I know I'm getting ahead of what's in the curriculum, but that's okay, because I want you to understand this. But the book definition of a subnet mask is it defines what portion of an IP address is the network portion, what portion is the subnetwork portion, and what portion is the host. It puts ones, 3, 4, 5, 6, 7, 8, into the network portion of the address, and zeros into the host portion. So when you look at this particular instance here, you can see that with this IP address, this mask, okay, this mask right here, it's saying the first 3 octets are the network portion. The last octet is the host portion. We're going to, one of the things that I want to do, and that I actually introduce, this is how I introduce it to my students, is I tell them about classical addressing. So one of the things I don't like about the curriculum is I don't like the fact it jumps right into VLSM. I believe you should actually teach classical addressing first and then move into VLSM. So back in the old days, we had class A addresses. Now, those addresses were any addresses beginning with the decimal value 0 through 127. If you will, mute yourself, please, if you're away from the computer. So the decimal value of 0 to 127. It also has in the first bit position. So this is the first bit position. It has a 0. Okay, and this is the decimal value here. And the default mask that you will find for a class A is 255.0.0.0. Okay, so class A addresses are large networks in terms of the number of hosts, but there are not many individual networks inside of it because there's only 1 octet given to it. In fact, one of the things that confuses people is that because the first bit's used up, there's only 2 to the 6th networks available in a class A. So for instance, if I write the address 10.0.0.1/8, and by the way, just so you know, /8 is shorthand for 255.0.0.0. Why does this equal this? Anybody know?
It's a cider block. That's your
Well, it's not necessarily a CIDR block, but and it is used for CIDR blocks, but it's the number of bits in.
Yeah, number of bits for the lot.
Correct, the number of bits in the subnet mask. And I always tell students it's just the number of ones turned on in the subnet mask. So a /8 mask would be 255.0.0.0. So that was class A, all right? Then we had class B. All right? They went from 128 to 191. The first bit positions are 1, 0, and the reason you'll see why, there's no way you can have 192 if you have 1, 1, 0, 0. You can't have 191 because you got the first two bits turned on. So everything that is class B starts with 10, default mask of 255.255.0.0. So we're going to put out here /8 and /16. Those are the default masks for those two. Class C is 192 to 223. It starts with a 110 and has a mask of 255. Actually, I think my handwriting's better on this board than it is in real life. All right. Now, we do have a class D, which is 224 to 239, and I'm not going to add anything else. It is 1110. And we do have a class E, which is 240 to 255, and they start with 11110. But our main classes were A, B, and C. Anybody know what D is used for?
Multicast.
Yep, D is for multicast. Anybody know what E is used for?
Experimental.
If you know, let me know, because all I've ever read is it's experimental and it's never really been used. So got no clue. All right.
That's all I've been told.
That's all I've ever said. All I've ever seen too. We're going to discuss these right here. That's going to be our main discussion, because one of the things I want to do for students is realize that class A, B, and C were great for a long time. Okay. But the problem we have is, imagine that I give you the following. I'm going to give you 10.0.0.0/8. Okay? So, what portion of this address is the network portion? If I ask you to write out the network of this address, what would it be?
10.
It would be 10, technically it's 10.0.0.0, okay? So that's the network, and then there's nothing here. How many bits you got in the host portion? You got 24, right?
24.
So you got 8 here, 8 here, and 8 here. So this is one network of a ton of hosts, which is good, okay, but it has some issues. Now, what if we put down 172.16.0.0/16? What class of address is this?
That's class B.
That is class B. So what portion is the network portion?
172.16.
Yep, there's your network. And then how many bits you got left over for hosts? 16 bits, right? So two like that. Then finally, 192.168.12.0/24.
Oh, that's class C.
Network portion's here. Host portion is here. So, in the way with our old school looking at classful addressing, class A's were a small number of networks with a large number of hosts. Class B's were a fairly large number of networks with a substantial number of hosts. I mean, 2 to the 16 is not playing around. That's still a good number of hosts. And then class C was a large number of networks with a smaller number of hosts. How many hosts are there on a class B here? Or excuse me, class C? How many total maximum hosts can you have?
Well, you have 255, and then you account for your network and your broadcast.
Right. The way to figure it is take 2 to the 8 minus 2 equals the number of hosts on any network. Okay? And H equals the number of host bits. So we got 8 host bits, so 2 to the 8 minus 2 equals 254 usable hosts on a class C, because there's only 8 bits. For a class B, it'd be 2 to the 16th minus 2, and then so on and so forth. That's all fine and dandy until your ISP does this to you. And look, folks, I know these are, I know for a fact that this is a private address, but I still use it for my students because, all right, so there's that, but here's my network. Okay, so there's a switch. Here's a router. It's another router. Here's a switch. And here's a switch. All right, I've got one. What is this? This is a class C, right? Do you agree with me?
Yeah.
All right. So it's one network of how many hosts? How many hosts are on a class C network, typically?
I mean, you can have.
By default, 2 to the H minus 2 equals number of hosts, right?
254.
Yes.
Correct.
Yes, 254.
So by default, we got 254. But now let's take a look at this network diagram. We got an issue because I need a network here. 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 And I need a network here. So I need 1, 2, 3, 4, 5. I need 5 networks. But my ISP gave me one network of 254 hosts. So I am now going to have to use a process called subnetting, which by definition is the process of borrowing host bits to increase number of network bits. That is the book definition of subnetting. Okay? Now, I'm going to teach you something called the 7 holy steps of subnetting. These 7 holy steps of subnetting were created by me one day. I can tell you how, but it's a story that I don't want recorded. What the heck. I was in the shower one day and I was studying subnetting, and I come up with it. I call them the 7 holy steps of subnetting. This is a joke, really, but... Now, this is for classical subnetting. It's not BLSM, it's just classical. Okay. But step 1, determine the number of needed subnets. We did that on our last picture. What did we say? We said that we need, we go back to it? Yeah. We need 5 subnets, right?
5.
You need 5.
So we need 5, we know that. Step 2, you write out your host bits. Now, once you get a little bit more advanced, you don't have to do this. I have my students do this because I want them to see that what they are doing when they subnet is they are borrowing host bits to increase the number of network bits. So as you increase the networks, you lose hosts. Okay? So this is the network we're working with. How many host bits do we have? How many host bits do we have right here in this particular network?
254.
You have 254 hosts, but how many bits do you have?
Oh, bits. Oh, you only have 8 bits.
8 bits. Okay, so let's write out the host bits. All right. Then, step step 3. Determine the number of bits you must borrow. Number of bits to borrow to get needed subnets. Now, I used to have a different formula for this. It used to be 2 to the n minus 2. But now, let me erase this because that's pretty bad. We can now use subnet 0. So the formula is now just 2 to the n. And n equals the number of bits. Oops. So how many bits do I need to borrow to get at least 5 subnets? Because we know we need 5 networks to make this work. Anybody know? 2 to what power will equal at least 5? 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. So we're going to make 8 subnets. Step 4, let me add, I'll go over here. Step 4 is turn on the number of bits you borrow. Now, turn them on means setting them to 1s. So what I do is I have my students go back to step 2 and say, okay, I've got to borrow 3 bits. So I'm going to turn on 1, 2, 3 bits. And the rest will stay host bits. Okay?
And where's the defined number of hosts?
We're not right now doing VLSM. We're doing classical addressing. So what we're going to do is we're going to create networks that are all the same size. And that's why I think it's important.
All right, that makes more sense to me now. It's getting lost.
Yeah, no, we have not defined. What we're going to do is we're going to create 8 subnets because we can't do just 5. We're going to create 8 subnets that are all the same size. And then I'll show you what we do. This is how I introduce VLSM. You're going to know when we create those 8 subnets that we're wasting a ton of addresses right here because you need 1 here and 1 here. This is point to point, right? That's how I use it. That's how I pivot to VLSM once I've taught them basic regular subnetting. Okay, so let's go here real quick. So we're going to turn on 3 bits. 1, 2, 3, 4, 5, 6, 7, 8. Step 5, you've got to have your new subnet mask. So you determine your new mask. And actually, I have them here. Turn this on and convert it. What is this converted to decimal? Remember that chart I told you to learn? I may have left it up here. Nope, I didn't. I still left that. I didn't erase that one. It's 224, right?
Yeah.
192 plus 32 is 224. So we're going to determine the new subnet mask. Now, how do we do that? You take the default mask and add to it what you borrowed. So the default mask for class C is 255, 255, 255, and then add to it 224. That's the new mask when you borrow 3 bits. Now we determine, some people call this the magic number. I call it the variable. Now in this case, we only have it in 1 subnet, but the variable in each octet. And you do that by doing the following. You look at where you turn on your bits, you find the least order bit going left to right, and determine the value there. What's the value at that position? You know, this is 2 to the 7, so it's 128, 64. So what's the value? 32, right?
So you start with the least.
Correct. You start with the highest order bit first. So you start here and count down.
Okay.
Yep. So you find the least significant bit, which is the one furthest to the right, and find the value there. So in this case, our variable equals 32. And then step 7 is determine your ranges. Now this is where we can do some This is where you have to, especially when you get into multiple octets, it gets a little weird. But we know we start with 192.168.12.0. That's the start, right? Now we need to go 32 different positions. So what are we going to put, where do we go from here? 0 to what? 0 to dot 31. And this confuses people because they go, we're supposed to go 32 positions. We did because we used 0. 0 to 31 is 32 positions.
Yeah.
Then, what is it, 32 to what? 63, right?
63, yeah.
64 to 95?
95.
96 to what?
32. 8, 9, 10. 128? Right?
Yep, but it'd be 127 because remember it's one less.
127. Yeah.
And 128. And some people just figure all the ones on the left-hand side. So what'd be next? It'd be 32 here, so it'd be 1, 3, 4, 5, 160, right? I think that's right, unless I screwed it up. Yep, that's right. And then that'd be 159 there, 160 or 191, 192, 223, 224, 255. How many subnets do we see here on this board right now, folks?
8.
8.
How many did I say we were going to have? I said if we borrowed 3 bits, we'd have 8 subnets, right? We got 8 subnets. Be aware that they call this one subnet 0 and 1, 2, 3, 4, 5, 6, 7. So it's still 8 subnets. But if you're ever asked to give subnet 1 of this particular setup, subnet 1 would actually be this, not the subnet 0. Okay? So read your questions carefully when you're taking a test or if you're doing any type of work for the curriculum. So folks, this is taking a single network, a Class C network, okay? The network 192.168.12.0/24, subnetting it so that it will fit this diagram, okay? And then now we can come back over here and we can actually use these subnets. So I can come over here and I can say, right here, okay, right there, I'm going to use green for this, but right here, I'm going to use 192.168.12.1 / now what is my slash notation for this new mask we come up with? Because remember, it doesn't work unless we use the new mask. So what's the slash notation for this?
That's 27, right?
Slash 27, exactly. So you take 24 plus 3. So I can take this network as slash 27. And then all of my hosts down here can be any number from .1 to .30 to be my host. And I've already used 1, so you couldn't use 1, you have to use 2. I can then come here and use the network 192.168.12.30 what? 32, right?
32. Okay.
So this would be 32/27. And then this could be .33, and this could be .34. Now, be aware, we're wasting a lot of addresses here. We're going to address that. Then we can keep going over and assigning each one of these to a different, network. So we took a single Class C of 254 hosts, and we subnetted it into 8 networks. Now, let me ask you this. How many hosts are left on each one of these networks?
Well,
can you tell me?
On the first one you got, let's see, you got, what, 29?
Use my formula. 2 to the 8 minus 2 equals the number of hosts. How many zeros you got left in the host portion?
You
5,
got
right?
5. So
What's 2 to the 5th power? Isn't it 30? to the first 2, 4, 8, 16, 32. So this is 32 minus 2. So the number of hosts on each network is 30.
And then the one, like on the far right, the one you used for the first network, that gives you, what, 29 left?
You talking about here?
Yeah. Yeah, where you did dot 1.
Correct, yeah. But, I mean, there's 30 total usable because I used dot 1. Yeah, dot 1 to dot 30 were usable.
For the host.
No, I'm sorry. That was the actual IP address I put on the interface. This is actually the .0/27 network. Dot 1 is the first usable host.
Dot 1's your first one, okay.
Correct. Now, I want to ask you something. Why is dot 1 the first usable and not 0?
Because 0 is your network.
Okay, I agree with you completely. But prove it to me. Anybody
I don't know. That's what
anybody
said.
Anybody from Missouri, the show me state, show me.
I know what the broadcast address is for, but I'm not 100% sure on the network definition.
Oh, yeah.
Let's look at it. Let's do 127.168.12.1. Actually, let's do .0. .0/27. I'm going to prove to you that this cannot be used on a host. And the reason I'm going to prove to it is because there's a rule, and that is that an IP address, okay,
Cannot be all ones or zeros,
cannot have all ones
or all zeros.
Oh, did
all ones or all zeros in the host portion of a network, in the host portion. Now, how do we figure out how to do this? Well, I'm going to teach you something that's exactly what your computer is doing with it. But first off, we're going to cheat a little bit. We're going to use a process called ANDing. And ANDing is a mathematical process by which basically this happens. If you put a 0 and a 0 together, guess what you get? 0. If you put a 1 and a 0, what do you get?
1.
0. If you put a 1 and a 1, a 1 and a 1 is the only time you get a 1. All right? So the mask for this is 255.255.255.2. Sorry about that, folks. I accidentally hit it with my hand. .224, right?
224.
Mm-hmm.
So I can go ahead and tell you without converting it to binary that these are going to fall through. Okay? I'm going to have 198.168.12 because if I convert that to binary and AND it, that will fall through. I'm going to prove it with just one of them. I'm going to prove it with 192. 192 is 11000000. I AND that with 11111111, which is 255, and I get 11000000, right? Which equals 192. Now we're going to take this though. We're going to look at this and we'll say, okay, we know that's our network. Well, let's look at the host portion. 1, 2, 3, 4, 5, 6, 7, 8. But now wait a minute. You're telling me /27. So the first 3 bits.
The first 3 are lost. Yep.
Those first 3 are network, right?
Yep.
Okay. Now there's nothing in this that says you can't have all zeros in the host and the network portion now. Used to, this was not allowed. This was actually legal at one time because it was called Subnet 0, and we couldn't use it. But we can use it now, so that's fine. But take a peek right here. What are all the host bits?
0.
They're zeros. So .0 is not usable.
Nope.
The first usable would be .1.
Come on.
Okay? Because then it would not be all ones. Now watch this. What happens when this becomes .31? 31, folks, is the following. 1, 2, 3, 4, 5.
Okay. Oh, fine.
So guess what?
Can I use it? Oh, what?
Can't use it because this is the subnet broadcast address. So there's all ones in the host portion. Okay? If it's all zeros, that is the actual subnet ID. Now watch this. I'll show you something cool. I'll show you something really cool. All right, let's go to 32. Convert 32 to binary. What do you get? 001, 1, 2, 3, 4, 5. Why can you not use that as an IP address on a host with a /27 mask? It's the subnet ID, right?
Yep.
Now, what's the last usable address in that subnet? Or what's the last address in that subnet? It goes .32 to what? So it's .32 to 63. So let's go back over here. If this was 63, the IP address becomes the following.
Or one.
That's what that is. All the host bits are what? Ones.
Once.
Broadcast. So as you will look, and in fact, the whole reason why you have the whole reason the formula exists, 2 to the 8 minus 2, is because these two, each one of these are the subnet ID and the broadcast ID. Subnet ID, broadcast, subnet, broadcast, so on and so forth. Okay?
So the host can't equal all zeros and then all ones, and then I knew all ones because that was going to be a broadcast, but I never thought, yeah, all zeros.
Can't be all zeros. Yep. Okay? Now, folks, I'm actually going to stop at this point because I think that's a pretty good thing. I want you to make sure you've read through the IP addressing chapter, which I know is coming up. And then we will, I'm going to stop sharing my desktop here. Are there any questions? I'm going to stop the recording, and then you can ask any questions you want. And see if it stops.